filming now. We're live. So today, what are we talking about? We're really talking about compound statements, all right? And we learned that if it's an or statement, then they're disjoined. It's called a disjunction. Disjoined, they go opposite directions. That's an or statement. We'll say it's this or this. A conjunction, they join, okay? And so that's an and statement because it could be greater than -2 and less than 3. Okay, that's an and statement. We can write it as a compound statement with two sets of inequalities, greater than, or less than. If they do shade away from each other, you can rewrite it as greater than. If they shade in between, it's shade less than, okay? Absolute value, we know that with absolute value, everything that goes in comes out positive. The graph of the absolute value of x is less than or equal to 3. Includes everything in between 3 and -3. Okay, that is a conjunction. We can write it as a compound statement. -3 is less than or equal to x, which is less than or equal to 3. Again, if you shade in between, make both inequality signs point to the left, okay? If it's an or statement and they're a disjunction, when you rewrite it as a compound statement, make both statements go to the left. All right, so now let's take a look at the notes, okay? So, describe the two graphs in set notation. So what we're going to do is this. Put x in the middle, okay? Put x right in the middle. So we want to describe everything that's going on. Now, if they are in between, it's an and statement. I make both inequality signs point to the left. So let's see. All right, it's an and statement. Make both inequalities point to the left. Put x in the middle. So I'll put -4 here and I'll put 2 there, right? Because it's in between -4 and 2. It doesn't include -4, so I'm not going to put a little equal sign here, but it does include 2, so I'll put a little equal sign there. Now, that is the answer. Let's see why. Let's read it backwards. Okay, read x first. X is greater than -4. Yeah, that looks like that, kid, right? X is less than or equal to 2. Yeah, that looks like it. Okay, so we rewrote it in a compound statement. Okay. Second example, it's an or statement. So we remember in an or statements, both inequality signs are going to point to the right. Greater than. Okay. So if you have to write this as a compound statement, put x in the middle. Put your greater than symbols, right? Put a -1 there, and we'll put a 2 here. No little equal signs, open circle, right? No little equal sign, no little equal sign, open circle. Well, does that make sense? Well, let's read it. Read x first. X is less than -1. Yeah. And x is greater than 2. Yeah, that makes sense. Okay, so we wrote that as a compound statement. Okay. Now, example 2. Solve for x and graph. All right, so I can solve for x. That's easy. -3. We have an x is less than or equal to -1. Or divide by 3. X is greater than 3. Now, if it says or, they should shade away from each other. Or shade away from each other. So let's go ahead and go -1. We'll go 0, 1, 2, and 3. I'm going to have a solid dot at -1 because it has the equal sign. Open dot at 3, right? If x is less than -1, it goes that way, right? And if x is greater than 3, I go that way. If I needed to write it as one statement, okay, so I got it shaded. If I needed to write it as a compound statement, I'd write it like this, with x in the middle. There it is, written as a compound statement. Remember, if it's an or, we make them both go that direction, right? Example 3 says it's an and statement, so let's go ahead and, am I going too fast? I'm okay? Okay, so divide by -2, but divided by a negative. What am I going to do? Flip the sign, right? Just divide by a negative, so I flip the sign and make it x is greater than or equal to negative 4. Plus 3 plus 3. Look at x is less than or equal to 5. Put my negative 4 down. Put my 5 down. I'll put 0 in there somewhere. You don't have to put all the numbers in between. I don't require that. Just require the two important numbers, right? The two answer numbers, and shade in the right way. Okay. So x is greater than or equal to negative 4. That's going to put me a solid dot, shading that way, right? But at the same time, x is less than or equal to 5, solid dot, and less than. So they do overlap, which does make it an and statement. Okay. Now, what I want to write is a compound statement, like squish it all together. Compound statement, squish it all together, put x in the middle, right? And I'll have my negative 4 less than or equal to x, less than or equal to 5. There's my compound statement, okay? So again, if it's an and statement, we know the inequality signs point to the right, okay? To the left, your right, my left. Okay, example 4. So we kind of looked at this. We know that all the values are going to be between 3 and negative 3, right? So what we really get is x has got to be less than 3, right? Because that's what it says. And then x is, now when we make it negative, we turn the sign. When we make it negative, we turn the sign. Greater than negative 3. So when we make it negative, we turn the sign, just like we did before. So when I make it negative, I turn the sign, didn't I? So let's graph that. I've got negative 3, I've got 3. And it says it's going to be less than 3, that's that way. Greater than negative 3, that's that way. So sure enough, it winds up being an and statement. Okay. If I wanted to write it as a compound statement, right, with two or more inequalities, I write it as x in the middle, negative 3, less than 3. Okay, it's simple. If it overlaps, both of the inequality signs are going to point to the left, right? Okay, this one, greater than 3 would be 4, 5, 6. But we also talked about negative 4, negative 5, negative 6. So we got two things going. We're going to have an x is greater than 3. Or we'll have an x is less than negative 3. So when I make it negative, I turn the sign. So when I make it negative, I turn the sign, right? Negative 3, 3, right? We're going to go open circle. Open circle because there's no little equal sign, right? See, to be greater than 3, that goes that way, doesn't it? Greater than 3 is definitely that way, okay? To be less than negative 3, that's got to go that way, okay? Now, if I want to write as one statement, I would simply do it like this. It's okay. Put x in the middle, greater than, negative 3, 3. Thumbs up so far? Okay, a couple of things to always remember. And statements. Your inequality signs point to the left, right? Or statements. Your inequality signs point to the right. Okay, as long as you have that, you're pretty good to go. Okay, now, example 6, a little bit different. You see, we wound up with two answers on both these, didn't we? 4 and 5, we wound up with two answers. We ended up with a positive answer and a negative answer. So watch and listen carefully. I need two answers. I need a positive answer and a negative answer because it's an absolute value, right? I need two answers. I need a positive answer and a negative answer. So my positive answer is just going to be 2x plus 1 greater than or equal to 5. So I didn't change anything. I just wrote it exactly the way it was without the inequality. Okay? There's my positive answer. My negative answer is going to be my 2x plus 1 is less than or equal to negative 5. So I use my negative answer. I just make the answer negative. When I make it equal to the negative 5, I turn the sign. Right? When I made it negative, I turn the sign. Now we're just going to solve like we always do. Okay? So I go minus 1, minus 1. 2x is greater than or equal to 4. Right? Divide by 2, divide by 2. I have x is greater than or equal to 2. Other equation, minus 1, minus 1. 2x is less than or equal to negative 6. Divide by 2, x is less than or equal to negative 3. Now, be careful. I did not turn the sign. I did not turn the sign because I never divided by a negative. I divided by a positive 2. Don't turn the sign. We turned the sign up here when we made it negative, didn't we? Okay, let's graph this. That's easy. Negative 3, 2, and 0's in there somewhere. Again, for me, all I need are the 2 important points. I don't need everything in between. If you want to put them, you can. So how do I graph this? Well, solid dot at negative 3, right? And it's going to be a solid dot at 2. It says it's greater than 2. That's going to be this way, right? It says it's going to be less than negative 3. It's going to be this way. Now, that is an OR statement because they go both ways, right? That's definitely an OR. So to write it as a compound statement, I'm going to use my double arrows, but they're all both going to be going that way, right? So let's see. I'm going to go x in the middle, right? Negative 3 and 2. And if we look at our notes, OR statement, they've got to go to the right, equal to, okay, there's your compound statement. How am I doing so far? Thumbs up, sideways. See 1 thumb up. See 2 thumbs, 3, 4, good. Okay, not bad. Okay, ready to turn the page? All right. Okay, example 7 is just like what we've been doing. It's exactly what we've been doing, except for one small thing. Let's get rid of this 2 first. There you go, example 7. Same stuff, but let's get rid of this 2 first. The 2 is not inside the absolute value. How would you normally get rid of the 2? Just the opposite. Let's multiply by 2, both sides. Because if I multiply by 2, the 2's a cancel, right? So all I've done is gotten rid of the 2. That's all I've done. So I've got still the absolute value of a 3x minus 9 is less than or equal to 24. Okay, now, with absolute values, we need 2 answers, okay? We need my next test I give you guys, don't forget, 2 answers, okay? So how do we get the 2 answers? Well, it has a positive answer and it has a negative answer. But when I make the negative, you gotta turn the sign. So when I make the negative, turn the sign. When I make it negative, turn the sign. Okay, let's solve now. Plus 9, plus 9. I'm going to have a 3x is less than or equal to, what's that, 33. Divide by 3. Got it? Plus 9, plus 9. What was that, 15? I think it's negative 15, isn't it? Okay. Divide by 3, divide by 3. Don't turn the sign. Okay. So far, so good. So I'll put negative 5, 11, right? Don't switch those around, please. Solid dots, right? Solid dot. Solid dot. Now, if it's going to be less than 11, it's going to go this way, but greater than negative 5, so they're going to kind of interlock, overlap. Okay, there's the number line. If I needed to write it as a compound statement, okay, I know that if it overlaps like this, then I'm going to call it an AND statement. I'm going to use my little arrows going both to the left, right? Okay, it's one of these, so I'm going to use both my arrows to the left. So we're going to write it as negative 5 is less than or equal to x, which is less than or equal to 11. There's my compound statement. Okay, example 3 is a trick question. Number 3 is a trick question. Why? Yeah, anything goes in always has to come out positive. Nice job. Smart girl. Anything that goes in always comes out positive, right? No matter what, it comes out positive. Okay, so tell me, do you know a positive number that's going to be less than negative 2? Do you know any positive number less than negative 2? No way. So what's our answer? No solution. Okay, so homework today. And then we'll talk about the tessellation here in a little bit. I'll get you guys started. 154. We're going to do 14 to 42 even. And number 70, okay? Not bad, okay. And so